All right, this is video 1 on piecewise functions. Let's look at our example here and see if we can figure out what a piecewise function is. So the Freewheelers Bicycle Club went on a Saturday bicycle trip. The graph shows the relationship between the time in hours and the distance in miles from the starting point for one female club member. She traveled away from her start point in a straight line. When the time started, she was already traveling at a given rate. Use the graph of D and the table to answer the following questions. So the very first question states, for this situation, blank is a function of blank. Remember, your independent variable is always going to influence your dependent variable. So if we've got time and distance, that tells me that distance is a function of time, because time will influence your distance. Number 2, write these labels on the appropriate axes with the units where distance is measured in miles and time is measured in hours. So what we'll have down here on the x-axis, this is going to be our time because that is our independent variable. So time measured in hours. And then on the y-axis, this is going to be our distance, which is our dependent variable. So this will be the distance measured in miles. Anytime you're dealing with units, always indicate on your graph what the units are so that the reader of the graph will know all the information that you're providing. So number 3, during which interval is she moving the fastest? Explain how you selected your answer. Well, without doing any calculations, we can say that she's moving the fastest on the interval from 0 to 2 hours. And the simple reason is because in this interval, the line is the steepest. When your line is the steepest, that means that we're going a further distance in a shorter amount of time. You're rising more than you're running. So our rise is distance and our run is hours or time. Describe what's happening on the bicycle trip for the first 2 hours. Well, for the first 2 hours, she has traveled a distance of 30 miles at a constant speed. And now let's look at number 5. The graph consists of 3 distinct line segments. So if you'll notice, from 0 to 2 hours, we have one segment. So that's one part of the piecewise defined function. Then from 2 hours to 4 hours, we have another segment. So that is the second part of our piecewise defined function. And then from 4 to 7 hours, we have our third segment. So we have 1, 2, 3 segments of this graph. Each segment represents something that's happening on this woman's journey in her bicycle club. But you're going to have different equations for each part, but all together they represent her whole trip. So if you'll look at this, our very first one says that the distance of our first interval between 0 and 2 hours is 15t. Well, let's see how they came about that. We see that the starting point here is at 0, 0. Because the starting point is at 0, 0, there's not a y-intercept. And then we're ending at 2 and 30. Well, if you use the slope formula, which is the change in y over the change in x, and you divide that out, your slope or your rate of change here is 15. So we're going 15 miles per hour, and so that is where the equation comes from, 15t. Now on the second interval from 2 to 4 hours, this is a horizontal line. Horizontal lines have a slope of 0. So if you extend this out, you'll see that it passes through the y-axis at 30. So our equation will be y equals 30. Since y is distance, it's d equals 30. And this is on the interval between 2 and 4. And now our third interval will be from 4 and 30 to 7 and 60. Okay, so let's calculate the slope. The change in y, 60 minus 30, over the change in x, 7 minus 4, gives me 30 over 3, which is 10. So that's my speed for that third interval. So since it's my speed, it's also my slope. Now, just pick one of the points that you're given here to write your equation in point-slope form. So we'll have t minus my x value, which is 4, plus my y value, which is 30. And then this is going to be the interval between 4 and 7. Okay? And so this is what a piecewise defined function looks like in the function form. This is what a piecewise defined function may look like on a graph. It's going to have different intervals representing different parts of the equation. Now, if you turn over and look on the back, it says, when is d equals 22 miles? When? What time? So d is your distance. So we're looking for 22 miles. So let's look at our graph again. So here's my distance. 22 miles is approximately right here. So if I follow it over to my line, I'm in that first interval, correct? In my first interval, our equation is d equals 15t, as long as the time is in between 0 and 2. So if the distance is 22 miles, I can replace d with 22 miles, and then I can divide both sides by 15. To get t is approximately, well, I take my calculator and I do 22 divided by 15. I'm going to get 1.47. So 1 47/100 hours rounded. So approximately 1.5 hours on that particular situation. Okay, what is the meaning of our answer? So that means we're going to travel 22 miles in approximately 1 47/100 hours. And then on number 7, it says, what is the average speed for the interval t equals 1 to t equals 3 hours? So let's get our graph again. Now, at t equals 1, right here, we follow up, and we're at approximately 15 miles. So 1 and 15, 1 hour, 15 miles. And then at t equals 3, we follow it up to right here at 30. So 3 and 30 for our ordered pair. Now we're looking for the average speed, which is the rate of change. Now we know that this is not on the same interval. One is from our first interval and one is for our second interval. But we're looking for average speed here. So you can use the slope. 30 minus 15 over 3 minus 1 is 15 over 2, or 7.5. Okay, since this is a speed, this is 7.5 miles per hour. Okay, so the rate of change was 7.5 miles per hour.